All right, in the last two lessons, we explored the inner join, which combined values that were found in both data frames. And in this lesson, we'll start talking about outer joins, which combine values that are found in either data frame or both. So before I dive into the actual pandas code, I wanted to show you this visually in this image. So in the last lesson, we explored the inner join, which is represented right here at the top. You can see we have two data frames, or imagine it as two data frames, A and B, and those values that were shared in common in the middle here in red were the ones that were pulled in. If I scroll down a bit here, these two options right here in the center and this one at the bottom are what we're going to be exploring in this lesson. So this is what Pandas does by default when we do what's called an outer join. It's going to combine the values that are in either data frame or both together. And then the alternative option is to take those values that are found in either data frame but not both. So either A or B but not both. So we'll dive into both of these examples in the code momentarily. But the key difference between these two is that center section that represents those overlaps, those parts where those values exist in both. In the default full outer join, everything's included. In this one below, the center part or the shared values are excluded, and only those that belong in either are represented. So let's take a look. I'll begin by executing our code to import our 4 CSV files, and I'll also preview the first two rows of our 2 weeks of sales, just so we have a reminder of what we're working with. And so the process for a full outer join is actually going to be very similar. We're going to begin with the week 1 data frame, and we're going to call the merge method directly on it. And as always, the very first argument is going to be the second data frame that we want to merge into week 1. So I'm going to write week 2. And at this point, we used to write that how parameter and give it that default argument of inner, which is again those values that are in common. In this case, we're going to change that parameter from inner to outer. And the on parameter is going to stay the same. I'm going to give it a single value of customer ID. So again, this is only possible because we have the exact same column name, customer ID, across both the week 1 data frame and the week 2 data frames. If we had different names, we'd have to use different parameters. We'll dive into that in a few lessons. So let's see what happens here when we just do the outer parameter. We're going to get kind of a combination of what we're used to. We have those suffixes immediately available at the top, which indicates to us that we have values from both the left data frame and the right data frame. And what I actually want to do here is immediately add those suffixes to make sure we have a greater sense of clarity here. So I'm once again going to do those suffixes and provide a list of strings. The first one is going to represent my left data frame, or week 1. So I'm just going to write week 1, and then my second string argument to this list is going to be week 2. And that's just going to provide us with a little bit more clarity on where this data is coming from. So how do we read this? Well, wherever we have no null values in a row, that means that that customer ID was found in both of the data frames. So in our very first row, for example, we have customer ID 537, and we have a valid value in the week 1 food ID column and the week 2 food ID column. What that means is that the customer ID with 537 came in the first week and bought food item number 9, and came in the second week and bought food item number 5. By the way, of course, the values here have been converted to floating points instead of integers, because behind the scenes, that's how Pandas needs to store them in order to account for those null values. We'll dive into that in just a second. Now that represents one possibility where we have the a value in both and in both the left and the right. So this is an example of the kind of row that would be included if we did inner instead of outer. But we're also going to get these values below, and wherever we have a null or blank, which is designated by this NaN, that indicates that that value does not exist in either one of our data frames. So what this means, because we have a customer ID of 97 and a valid value right here, that means that customer number 97 came in and bought food item number 4 in week 1, but did not come in week 2 and did not buy anything on that second week. Now, why is it stored here? Well, because Pandas needs to combine both of these data frames together and merge them, Pandas needs something to store in that cell that basically represents nothing or blank. it needs to combine these two columns in order to have those that are actually full matches. And wherever it can find a match, it has to provide a null value. And this is also going to operate in reverse. If I scroll down closer to the bottom of my data sets, here you can see a whole bunch of null values in my week 1 column and valid values in my week 2 column. What that indicates, for example, in this one is that the customer ID 622 did not come in on my first week. They did not purchase anything, but they did come in on the second week and buy the item with an ID of 9. So wherever we do have a match, we're going to combine them into a single row. And wherever we do not have a match, we're going to have one of the cells have a null value. It's either going to be the left one or the right one, depending on which data frame does not have that value. Now, because we're combining those rows that have common values together, we are going to have less rows in this final data frame than we have if we had just concatenated them together. So we know that week 1 and week 2 both have 250 rows. So if we concatenated them together, we'd have a data frame of 500 rows. This data frame in comparison is still going to have all of our customer IDs represented, but those that match are not going to be just placed on top of each other. Rather, they're going to be merged on the common line, while those that are not represented are each going to have their own separate line with a null value. So this data frame is going to be significantly shorter. And what this basically means is that 454 rows exist compared to 500, which means 46 of those rows represent those where it was able to match the customer ID together. So our inner component, so to speak, of this week 1 data frame has 46 rows. There are 46 rows. Let me just remove this. There are 46 rows where we have a valid value for both the food ID in week 1 and the food ID in week 2. Wherever it merges, it's basically able to cut out an extra row. Wherever it's unable to merge, it basically has to keep that row and just apply a null value. So that means there are 46 customer IDs that are found in both of them. Now, another great thing that we can do in addition to the null values is to offer a visual indicator of where the value is being pulled from. And there's an additional parameter available here called indicator. You can see it's set to false by default. I'm actually going to put a comma and place it on the next line here. And I'm going to set it to true. And what this parameter is going to do is create a column, an additional brand new column on the right side of my data frame that's going to tell me where the value is being pulled from. So let's take a look. You can see that we've had this underscore merge column added to the right, and it's basically going to state the status of that row. So both indicates that the value, in this case the customer ID that we're merging on, was found in both data frame 1 and data frame 2, week 1 and week 2, left and right. In comparison, as we see visually here by the presence of a valid value in week 1 and a null value in week 2, this indicates that the customer ID 97 was only found in the left data frame, or week 1. In comparison, if I scroll down to where I have valid values in my week 2 column but nulls in my week 1 column, you can see that that indicator tells us that that customer ID of 622 was only found in the right data frame, or week 2. So that's a great indicator to show us where the data is coming from. And what's great about this, what I'm going to do here is assign this to a variable so we can continue to call operations on it. We can call, let's say, call this merged, which will be our variable. I can take a look at merged and extract that merge column. Keep in mind that it has that underscore. And I can call the value counts method on it to take a look at how the values are distributed. So it's going to tell me that 197 unique customer IDs exist in my right data frame, or week 2. 195 unique customer IDs exist in my left data frame, which is week 1. And those two data frames share 62 common customer IDs in common. So that's how this method can be particularly helpful for getting a sense of where this data is coming from. Furthermore, the really great part about this is that we can use this to cut out those values that they both share. So what I can do here is call merged, and if I want to pull only those values that are in either a left or right, but not both, I basically have to cut out this both criteria. Now there's several ways to do this, but what I can do is this. I can do create my filtration process. I'm going to, actually, let me just do this. Let me just show you how I'm going to create my Boolean series. There's my merged column, and I'm going to call the isIn method, which you may recall takes a list, and it's going to return true if the value is found in that list. And I'm just going to pass left only and right only. So what it's going to include is those that are found in either one and only one, so either left and only right. And those that have values like both are not going to be found in this list, so they're going to return false. So in this Boolean series, true is basically telling us those values that exist in either but not both. And now if I pass this Boolean series, let's assign it to a variable, and pass it to my original data frame, this is basically giving us a data frame of those rows or those customer IDs now that are present in either week 1 or week 2, but not both. So basically what we've done here is transition from this, which is our first result, everything included, including those in common, to this second result on the bottom where we have every unique customer ID from week 1, which is A, every unique customer ID from week 2, which is B, but we've cut out those that are both. So the center remains white. It remains excluded in this second option that we have here. So that's how we can use the indicator in order to very easily find out values that are in either data frame but not both. So that's an introduction to outer joins. Again, a different operation depending on what you need your data to do. If you want to find values in common, you want to rely on the inner join. If you want to find values that are in either data frame and both, you can use the standard full outer join. If you want to see values that are in either data frame but not both, you can begin with a full outer join and then extract that center component by using things like the indicator to remove those values that are both. And basically just find the data or combine the data in exactly the way that fits whatever business inquiry you're trying to answer. So that's the outer join, and in the next lesson we're going to start doing a direct join, which is called a left or right join, which is the closest thing to something like a VLOOKUP operation if you're familiar with that in Excel. So plenty more to dive into this module. I'll see you in the next lesson.